This is my conduction temperature project, Challenge Assessment 3. My name is Leo Edwards. So this is problem 3 from the handout. For some background, I did calculations that I turned in separately. So for the background, I did a sphere that is generating heat and dissipating it into the environment at a steady state. This is important because I started with the heat conduction equation and worked with it to get a formula that would be a function of the distance, so being the radius of the sphere, and it would give me temperature. The graph that I believe I'm currently covering up shows the temperature in Kelvin versus the radius in meter of the sphere. As you can see, we start high and gradually decrease. This looks like a first order function. As you move from the center of the sphere, it becomes cooler. For this experiment, I changed 3 things, so I had 3 parameters. Here, I was able to change 3 things 3 times, if that makes sense. I changed it 3 times so that I was able to compare it to itself. Parameter 1 was the initial surface temperature. I changed it, and it looks like on that first graph at the top there, no matter what I change, it still looks like the same first order function. So it looks the same. Parameter 2 was the conduction value that I changed. I'm covering it up right now, but I'm going to move this photo to show you that no matter what the conduction is, it's always going to come down to just about the same temperature when you get to 0.04 meters away from the center. This is super interesting because the hotter it may start out, the faster it's going to cool down to reach that temperature. For parameter 3, I changed the energy generated. It looks like no matter how high you start, it's still going to be able to come down to that 0.04 temperature, the same as everything else. Let's say that I wanted to try and keep this sphere as hot as I can for as long as I can. There are some things that you could improve and some negative effects that you could have happen. Let's start with the improvements. Changing the conduction value would be an improvement. Having a lower conduction value might make it so that you start at a lower temperature, but you would be able to retain that heat for longer. Changing the radius of the ball, you would be able to have a larger ball and keep more heat throughout the distance of that ball. You could also wrap it in insulation to help keep the heat in there. Some negative effects that you could have if you wanted to keep your ball as hot as possible. You could change materials. This might help dissipate heat faster than you would want. Or having a higher surface temperature might not help you, or extremely low surface temperature might not help you.